Oh boy, it's some more physics time. We're going to be looking at motion and displacement today. Uniform motion is very unique. Uniform motion is almost perfect motion. It means that you are moving the same distance every point in time. So that's kind of confusing, but that means you're like cruise controlling. You're traveling down Highway 2 at 110 kilometers per hour. So every time you check your point in time, you've traveled the same amount of distance. So if you say, I'm going to check how far I've gone every hour, you would have gone 120 kilometers in that hour. But uniform motion is really hard to pull off. Those of you who've started to drive, or those of you guys who have bikes, you'll know you can't travel the same speed in a straight line forever. Eventually, you're going to have to brake or turn, and that's non-uniform motion. That's changing distance over time. Non-uniform motion deals with something we'll talk about later this week or early, and when we get back, called accelerated motion. You can go faster. That's like putting your pedal down or going down a hill, picking up speed, and you can decelerate, meaning that you're braking or slowing down. So non-uniform motion and uniform motion are a little bit different. Okay. Now, you guys have, if you printed off the note pack, you have this little graph. If you have uniform motion, the line looks very, very straight. So object B is going through uniform motion. Every time we check, it's gone the same amount of distance. Like if I put a little dot here and I say I'm going to check every 2 seconds, and then I put a little dot here, you can see that it might be a little off because you don't have a scale, but every time I check, it's gone the same amount of distance if I check every 2 seconds. If I check every 1 second, if I check every 5 seconds, or whatever, object B has gone the same amount of distance in that time. It's going in uniform motion, and you can see how straight the line is. It's a very straight line. Now, object A is non-uniform motion. Now, while uniform motion is easier to wrap your head around, non-uniform motion is more realistic. If we look at this picture, something kind of weird is happening up here. It's almost like as we're going, it's changing distance is almost zero. So it could be stopping. Right? If we look at this part of the graph, it's not moving anymore. Look, the distance every time we check isn't moving. And as well, we have some curves. So usually if you see a non-straight line, it's non-uniform motion. Okay, I don't know if this is in, that's not in your, let me check your notepad here. Sorry, everything's a little discombobulated. I mean, to make sure, instantaneous speed, yeah. Okay, so I better cover that because that's in your notepad. Instantaneous speed is when we take a snapshot in time. So that would be like in a 2-hour car ride, how fast are you going at time 1.5 hours? So those of us who have driven to Calgary or Edmonton, or you've been in a car ride going a long distance, instantaneous speed is a snapshot. It'd be like in that entire journey, exactly at 1.5 hours, How fast are you going? Now, that's not indicative of the entire trip. You could be at 1.5 hours booking it on Highway 2. Or at 1.5 hours in a different scenario, you maybe could have been going faster, but you were behind a slower vehicle. So it's the speed at that moment in time. Okay? Non-uniform examples deal with the whole trip. Okay. So we'll get to that a little bit later. What we're going to look at today is the start of velocity. Yesterday we looked at speed, and a quick review of speed. Speed is how far you're going over time, distance divided by time. Velocity is a very similar formula, but velocity has an arrow over it, and the distance has an arrow over it. And we're going to talk just today about what this special unit is. It's called displacement. Okay, so you can fill in the blanks if you've printed off the study guide, or you can listen along, or you can, if you printed off the notepad. In average velocity, we always need to use displacement. Okay, displacement is always how far you've gone, how far you are from the start, not the total distance traveled. So we're going to do some examples on that. And we don't call it distance. It's called, like I said again, displacement. So it's a completely different term. Now, we're going to be using something called tip to tail to calculate, but there's some shortcuts I'll show you. So all we're worried about today's little mini lesson, is calculating displacement. The difference between distance and displacement is if this is where you start. Distance is concerned about how far you've gone total. Excuse me. And that's like if you're on a hiking trail, right? Maybe you went 10K on a 10K hike. Displacement is when you get to the end, how far are you from the start? Maybe here you're 7K. Now, obviously, you can't go through the middle here, probably because there's scary clowns, but that's the difference between displacement and distance. Displacement is from the start, how far you went. Okay? So here's an example in your notebook. Okay? Let's say Mr. Zed's rig travels 17.5 kilometers north of Bragg Creek. It does some work, and then it comes south 16.5 kilometers. What's the displacement? Now, if we wanted to figure out the distance we've traveled, this would be very simple. We would just add the two together. And if we added 17.5 to 16.5, we get 34 kilometers. Now, that's not displacement. Displacement wants to know where we are from the start. Okay, so I'm just going to get rid of all of these highlighted boxes. There we go. So we're going to use something called tip to tail. If this little part here is the start, and I go 17 kilometers north, you'd think of like the compass, north goes up. Do we all agree north goes up? Okay, it goes up. So we go 17.5 kilometers up. Then the rig comes back 16.5. So how far did we actually travel from the start? That is this little distance. And if we figure out how far we are from the start, we're 1 kilometer. Why are we only 1 kilometer from the start? Well, we went 17.5 north, came back 16.5. So from the very beginning, we are just 1 kilometer shy of the start. Now, the other thing we have to do in displacement is we have to tell which direction we are from the start. Are we north of the start or are we south of the start? Okay, so if this is the start, up from there is north. Now, if you don't like drawing little diagrams, we're going to do a couple more examples of this because it is tricky. You can make some quick calculations. You can say North is positive and south is negative. So if you're going to, and then you just add the two different directions. So I'm going to go 17, which is positive. I'm going to add that to 17.5. 17.5, which is positive, and I'm going to add that to south 16.5, which is negative. So when you add a negative, you're really subtracting, and you get 1. And because we wound up with a positive value, and we said positive values are north, we're 1 kilometer north. Now, you could just use logic and say, oh, if I go 17.5 up and 16.5 back, I'm 1 up, and that's north. You don't even have to do a diagram. You can just do the calculations in your head. So there's lots of different ways to do displacement. Now, we're going to try a couple more here. So if a vehicle travels 50 kilometers south, turns around and travels 75 kilometers north, stops, and then travels 90 kilometers north, what's the displacement? Okay, so you could draw a little picture. You could say, okay, all right, I'm going to say this direction is south and this direction is north. So the car goes 50 kilometers this way, all right? Then we turn around and we come back 75 kilometers north, and then we go another 60 kilometers north. How far am I from the start? Well, this is how far we are from the start. Now, you're going to have to do a little bit of math. What some kids like to do is they're like, all right, I'm going to add the norths and subtract the south. So I'm going to go, okay, 75 north, 60 north, and then I'm going to subtract the south, because that's kind of the difference between the two, right? And we wind up with a difference of 85 kilometers north. So from the start, we're 85 kilometers. I added 75 and 60 together, and then I subtracted 50. Okay. And then you can also decide to do it a different way. You could say, all right, I'm going to say north is positive and south is negative. Okay, so I'm going to go negative 50 plus, because that south we said is negative, plus 75 plus 60. And I wind up with 85. And then that's a positive number, so I'm going to say that's north. 85 kilometers north. You could just logic it out and say, okay, all right, so if I go 50 south and 60 north, that's net 10 north. I'm going to add 10 here as 85. So you could do this really quick if you can do mental math pretty good. There's lots of little tricks to displacement. Okay. So I'm going to do this one with a pause. You guys can try this. I'm going to do like a pause like we would do in class. So a crazy clown chases Mr. Z 14 meters east, 25 meters west, and then 9 meters east. What is Mr. Z's displacement? Are you going to draw a picture where it looks like this, west and east? Are you going to say west is positive, east is negative? Doesn't matter. You got to figure out a way. Where's Mr. Z? Okay. Here's what I'm going to do. I don't necessarily like the tip to tail drawing a little picture. You can do that if it helps. I like mathing it out. I'm going to say that east is positive and west is negative. So I'm going to go, okay, 14 meters east. I'm going to add that to, we're going west, which I said is negative. And I'm going to add that to, we're going east. I said east was positive. And then I can add that all together. 14 plus negative 25 plus 9. That gives me a total of minus 2. Now, what did we say it was minus? West. 2 meters west. Another thing you could do is lump up terms. So that's east. 14 plus 9 is 23 meters east. And we have 25 meters west. So logically, the difference between that is 2, and we have more west than we have east. That's displacement. Okay, you guys are going to do a couple Google form questions to see if you know how to do it today. That's the plan for today.